Welcome to Vision Plus and welcome back to this senior for mathematics on complex numbers. We are now looking at the polar form of the complex number and we are starting with example 1. Before we go to example 1, we are saying that the polar form of a complex number is also known as the modulus argument form of that complex number, and it is in this format. It is given by the complex number z in the polar form is r into cos of theta plus I sine of theta. And this also can simply be written as that the polar form is z is r comma theta. Why are we doing that? We have said that a complex number is a sort of a vector quantity. It has the magnitude and the direction. The magnitude of the complex number is what we are calling r. The argument of the complex number is the direction of the complex number. So any complex number is defined by its magnitude and its direction. So these two forms give us the polar form of the complex number. So if you are asked to write any complex number in the polar form, you can either use this or this. They are the same. Now, coming to example 1. Example 1, I say that we need to write the following complex numbers in the polar form. Part A says that we need to write 4 plus 3i. So what do we need to do? For it to be in this form, what do we need? We need the magnitude of the complex number and the argument of the complex number. So to this complex number, which you can just say let z be that complex number 4 plus 3i. Now, what do you need to do? You need to find the magnitude. So r, we are saying it is the magnitude of the complex number z. This means that we know that the magnitude of the complex number z is given by the square root of x squared plus y squared, where x is the real part of the complex number, which is 4 squared, plus y, which is the coefficient of I squared. And then you press your calculator. 16 plus 9 is 25. 4 squared plus 3 squared is square root of 25. This gives us a square root of 25. Then you press the square root of 25. We shall have here 5 units. Remember, this is the distance, so we take the positive part. So we have got r. Therefore, this is r, or the modulus of the complex number. Now, let us go on to find the argument of this complex number. We have seen how we find argument of the complex number. We start by drawing. We start by drawing or representing it on the Argand diagram. This is the real axis of z, since we have called it here z. This is the imaginary axis of z. Our board is not stable, disturbing. At the origin here we have the center O. Now we need to represent this. I'm going to be fast in representing that because we know it already. So I'm going to have here negative 4, 4, I'm going to have here 3, and here negative 3. And then the complex number, both are positive. So they are going to meet somewhere there. Somewhere there. This is where they're meeting. So you get your ruler, then you draw a straight line. Use a ruler, please. And now we're going to look for this argument. Now, that argument, we are supposed to extract this triangle and we redraw it here. But I'm not going to do that. Please go ahead and do it. Because I can be seeing the triangle here and I extract what I want. So we are going to use SOHCAHTOA, and for which we are going to use tan. So we shall just say tan of theta equals to It is opposite of adjacent. Opposite is going to be 3, adjacent is 4. So going to be 3 out of 4. That means now theta becomes tan inverse or arctan of 3 out of 4. Had this somewhere, it was around 30 something. 3 divided by 4, tan inverse 36.87. This gives us 36.87 degrees. So after getting the argument and the magnitude r, then we come and substitute. Therefore, the complex number that we have called z equals to, let me first quote the formula, cos of theta plus I sine theta. Now this becomes 5 into cosine of the angle. What is the angle? We have 36.87 degrees plus I sine of the same angle, 36.87 degrees, then closing bracket. This is the polar form of the complex number, or simply you can just say z is given by, we have said it is r, comma, theta. That means what is r? It is 5, comma, what is the angle? 36.87 degrees. So either you put this is correct, or you put this is also correct. So this is the solution to part A. Let us go to part B.